Hello students, here we have some more partial differentiation problems. Here z is given as tan inverse y by x, then prove dou square z by dou x square plus dou square z by dou y square equal to 0. So for that z is given, and here we have 2 times partial differentiation of z with respect to x. That's why first of all we can take partial differentiation of equation 1 with respect to x. Then dou z by dou x equal to dou by dou x of this. So it is in the form like tan inverse x. Tan inverse x derivative is 1 by 1 plus x square. So 1 by 1 plus, instead of x here y by x is there. So again instead of x we have y by x. So differentiate this again with respect to x means y is constant, y take it as it is, and 1 by x derivative is minus 1 by x square. Like here take the LCM here by x square and take it into numerator x square by here x square plus y square and into this as it is, and x square gets cancelled and we have minus y by x square plus y square. Similarly, we can take this with respect to x again, because in the question it is given that dou square z by dou x square. That's why partial differentiation of equation 2 with respect to x. Then it is dou square z by dou x square, here dou by dou x of this one. Again here with respect to x we are doing means y is constant, so minus y constant as it is. And here it has x term, that's why it is a function like 1 by x form. 1 by x derivative is minus 1 by x square. So minus 1 by, instead of x, this part x square. Again instead of x square plus y square is there. So differentiate this with respect to x in the sense x square derivative is 2x and y square derivative is 0. So here it is nothing but minus into minus plus 2xy by x square plus y square whole square. So similarly, what is the next one? Dou square z by dou y square. For that, first of all, partial differentiation of equation 1 with respect to y. Then it will be dou by dou y of this. Again it is in the form of like tan inverse of y, that is 1 by 1 plus y square. Y square means y by x whole square. Again dou by dou y of y by x. So dou by dou y of means x is constant, so 1 by x as it is here, and y derivative is 1. So 1 by x into 1 is 1 by x. Now here we have take this as LCM x square and take it into numerator. So x square by x square plus y square and 1 by x square x. Then it gets cancelled. That means here we can write it as what? X square by this by x square, take it into numerator, and this LCM means x square plus y square into 1 by x. Now x gets cancelled, then x by x square plus y square. Again this partial differentiation of this with respect to y. So with respect to y means x constant here, take it as it is, and this is in the form like 1 by x, so minus 1 by x square. Instead of y here this term, so with respect to y means this is constant 0, and with respect to y means this derivative is 2y. So here minus 2xy by x square plus y square whole square. Now adding, because in the question it is given addition of these two. So add this and this. Then what will happen? Same with opposite sign. So gets cancelled, answer will be 0. See the next one. Z of x plus y equal to x square plus y square. Then show that this part. So z of x plus y equal to this, so we can write it as z equal to x square plus y square by x plus y. Now partially differentiate equation 1 with respect to x, because in the question it is asking that dou z by dou y, dou z by dou x. Here also same. So we need to take the partial differentiation with respect to x and y. That's why dou z by dou x. So dou by dou x of this part. Here it is a function by function. So u by v form. So what is the derivative of u by v? D by dx of u by v is u dash v minus u v dash by v square. So derivative of numerator means what? 2x into denominator as it is minus u into v dash. U means this as it is, derivative of x with respect to x is 1 plus 0, that is nothing but 1 by v square. V square means x plus y whole square. Now multiply this, 2x square 2xy minus x square minus y square. Now x square, 2x square minus x square minus y square plus 2xy by denominator is same. Again partially differentiate equation 1 with respect to y, because we want dou z by dou y also. That's why dou by dou y of this. Again it is in the form of u by v, where u by v formula is this one. So u dash means this with respect to y it is. So y square derivative is 2y. Of course, it is a constant. So derivative 0 plus 2y. That is 2y into denominator as it is minus u into v dash. With respect to y means y derivative with respect to y is 1 by v square. Now again multiply these terms like this. Then it will be 2y square minus y square is y square minus x square plus 2xy by this. Now we need to prove this one. For that, take LHS part. What is LHS here? Dou by dou x minus dou z by dou y whole square. So this minus this whole square we need to do. See here, after substitution, simplify this. Here, denominator is same, so take LCM. So x square minus y square plus 2xy minus of this minus y square plus x square minus 2xy, and 2xy minus 2xy gets cancelled, and x square terms are 2, so 2x square minus 2y square, take 2 as common, x square minus y square by x plus y whole square. Again whole square will be there, so take it whole square. Now 2 square is 4, and x square minus y square can be written as x plus y into x minus y by this is nothing but x plus y whole square. Again whole square. So this 4 outside, and this x plus y gets cancelled here. Here x plus y whole square, so 1 x plus y gets cancelled. Now x minus y by x plus y here, 4 into whole square here, this whole square. Okay, now similarly take RHS. RHS is 4 of 1 minus dou z by dou x minus dou z by dou y. Substitute all those values. Again take LCM as x plus y whole square. Then it is by 1 in the sense x plus y whole square into 1. X plus y whole square is nothing but x square plus y square plus 2xy. Minus of this multiply and minus of this. Then x square terms are cancelled, and 2xy term cancelled, y square term is also cancelled. Then what will be the remaining one? X square y square minus 2xy by x plus y whole square. It is in the form like a square plus b square minus 2ab means a minus b whole square. So x minus y whole square here, and x plus y whole square. Sure. So here 4 into x minus y whole square, already it has x plus y whole square. So take a square by b square is nothing but ab whole square. So 4 into. So here we got LHS and RHS equal values. That's why these values are equal. Here is the question: u equal to 3 of Lx plus my plus nz whole square minus x square plus y square plus z square, where L square plus m square plus n square equal to 1. We know this in direction cosines. L square plus m square plus n square is 1. This condition is also given. Then prove that dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square equal to 0. Here we have second order partial derivatives with respect to x, y, z. That's why we need to find that values. For that, u is given, take it as it is. Now partially differentiate of equation 1 with respect to x, then dou by dou x of this u total. Then see, with respect to x we are doing. So in this we have x term, so it is a function. Then here constant into function, so take the constant as it is, and this is like which form? Function square, that is x square form. X square derivative is 2x. X means this one. Again differentiate this with respect to x, minus x square derivative is 2x plus y square derivative with respect to x means it is a constant, so 0. Z is also a constant when you are taking with respect to x, that's why it is also 0. So only here minus 2x. So here 6, this same term, and dou by dou x of Lx is L minus 2x. So 6L of Lx plus my plus nz minus 2x. Similarly, with again we need to take partial differentiation of this one with respect to x again, then dou by dou x of this total. Again with respect to x we are doing means 6L is constant and Lx derivative is L, and these are constants because with respect to x we are doing means y and z are constants. So zeros. Here only L minus 2x derivative is 2. It is nothing but 2L square minus 2. Similarly, when you are taking y with respect to y, again with respect to y, instead of L we are getting m because these degrees are same here. Okay, so instead of L you keep m, then we got dou square u by dou y square. Similarly, for dou square u by dou z square, 6n square minus 2. So take LHS dou square u by dou x square plus this, then adding these right side values, then 6 taken as common, then L square plus M square plus N square, minus 2 minus 2 minus 2 is minus 6. So here already given that this value is 1, so 6 minus 6 is 0, hence proved. See this problem, u is given, then show that these two conditions. First of all, in the first one, we have this whole square of u, it is given, right? So it is not like dou square. What we need to do is this whole square of u, in the sense 2 times we have to take this one, dou by dou x plus dou by dou y plus dou by dou z of again dou by dou x plus dou by dou y dou by dou z of u. Now take this part as it is and we need to take the expansion of this dou u by dou x plus dou u by dou y plus dou u by dou z. Now partially differentiate equation 1 with respect to x, because we want dou u by dou x, dou u by dou y, dou u by dou z. That's why we need to take partial differentiation of u with respect to x, then dou by dou x of this. See here, this whole square, it is not equal to dou square u by dou x square. It is, in the sense we need to take second order partial derivative here. Here we need to take like this of. So these both are different. So see here, dou u by dou x means dou by dou x of u. So log x derivative is 1 by x here. Instead of x, this total part we need to substitute. Again dou by dou x of 3x square, x cube is 3x square, and here 0 0 because they are constants, and minus 3yz constant as it is, and x derivative is 1. So answer will be 1 by this part into 3x square minus 3yz. So next one, partial differentiation of equation 1 with respect to y means dou by dou y of that u. Then log x derivative is 1 by x, but instead of course 1 by y, with respect to y means log y is 1 by y, instead of y this term. So again differentiate partially with respect to y. So x is constant, z is constant, so 0 0, and y cube derivative is 3y square minus 3xz constant, and y derivative is 1, so 3xz. Similarly, with respect to z means 1 by this as it is, and this is 3z square, and this is 3xy constant, and z derivative is 1. Now adding all this. When you are adding all these, what will happen? In the denominator, same term is there, and in the numerator, when you are taking 3 common, then x square plus y square plus z square, again minus xy minus yz minus zx, and also we have one formula for this, x cube plus y cube plus z cube minus 3xyz is nothing but x plus y plus z into this part. So same part is common, so gets cancelled. So we need to remember this formula as x cube plus y cube plus z cube minus 3xyz is x plus y plus z of x square plus y square plus z square minus xy minus yz minus xz. So same term gets cancelled and it will be 3 by x plus y plus z. Now again we have dou by dou x plus dou by dou y plus dou by dou z of this value, right? This value, it is nothing but this. Substitute here. Again dou by dou x of this part plus dou by dou y of this part, and plus dou by dou z of the same part. So here 3 constant as it is. Here x term with respect to x means it is like 1 by x form. 1 by x derivative is minus 1 by this total whole square. Again derivative of x is 1 plus derivative of y and z are zeros. So see, 3 into 1 by x is minus 1 by x square. Again d by dx, dou by dou x of this is 1. Here 0 0. Now 3 into, similarly we can do for the next one. Similarly with respect to z means same, minus 1 by this whole square. Again with respect to z, z value is 1, remaining all constants. So here minus 3 minus 3 minus 3 by denominators are same, take it as it is. So minus 9 by this. So this value is minus 9 by x plus y plus z whole square. Similarly second part. So in the second part, it is asking that dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square. In the sense we need to take partial differentiation of u with respect to x 2 times. So already we have done in the previous problem dou u by dou x, this value is this. So again partial differentiation of u with respect to x means dou by dou x of this part. Now it is in the form like u by v. U by v derivative is u dash v minus u v dash by v square. So u dash, in the sense this total derivative is 6x and this is independent of x, that's why it is a constant whose derivative is 0. So 6x into v as it is minus u as it is, and v dash derivative of x cube is 3x square minus, this is what with respect to x means y z constants, minus 3yz constant as it is, and x derivative is 1, so 3yz by v square. V square means this total whole square. Again multiply each and every term, like 6x into x cube, x power 4, 6xy cube, like that each and every term we have to multiply. Here also minus of 9x square into 3x square into 3x square is 9x power 4. First into second, second into first, second into second. Now divided by denominator as it is. Again after simplification, here minus 18x square yz, after taking minus into these terms, then plus will be there, gets cancelled, remaining terms as it is. Now take x power 4 terms, here minus 9 plus 6, so minus 3x power 4. Again xy cube, here 6xy cube, next only 6xy cube, here xz cube as it is. Again minus 9y square z square by total. Similarly, dou square u by dou y square means no need to do all again because the powers are same here. That's why simply what we need to do is minus, instead of x you keep y, y interchanges as z, instead of z you take x, replacing x by y by z, z by x. So here minus 3, here y power 4 plus 6, x means y tends to z. Like this we can substitute for every term. Here y, here z means x. Here y for z, z means x. Like this in the denominator also we can do. Then it will what happen? Y cube plus z cube plus x cube is nothing but x cube plus y cube plus z cube minus 3xyz whole square. Similarly for z also, instead of y you keep z. Like this we can replace y by z, z by x, x by y. Like this we can get these values. So adding all these three values, this plus this plus this. When you are taking minus 3 common here, just multiply all those terms by denominator is same, so take it as it is. Denominator whole square is there here, so as it is. Now minus 3 taken as common, then this will be x power 4, here y power 4, here z power 4. Like this we can take minus 3 common, then write all the remaining terms divided by denominator is what, this whole square into this whole square. Now how to simplify this one? It is so lengthy, right? So simply remember that what is the question given? This is, we need to prove that minus 3 by. So minus 3 by, this already there. So these must get cancelled, right? Now instead of that what we can write is, here what is that? X square plus y square plus z square minus xy minus yz minus zx whole square is nothing but this total. Observe here, x square whole square means x power 4, y square whole square means y power 4, z square whole square means z power 4, minus 2ab means x cube y term is there. So like this every term is there here. So according to the answer also we can guess that it is nothing but what, this total is nothing but this part. So take it as it is, x square plus y square plus z square minus xy minus yz minus zx whole square means when you are expanding this, then same will come. So this expansion is nothing but this one, so gets cancelled. Then we got minus 3 by x plus y plus z whole square, hence proved. Thanks for watching.